So, in the previous lectures, we have designed concept, network, and analyze it. Okay, and 2D also with the channel. Okay, so now we will create one pond over there, which will accumulate the flow from uh, this area. Okay, so we need to find out what's the maximum volume it is passing through this outflow node. So this double click, you can see the results and the down inflow. Okay, that is coming upstream inflow, it is coming 16,140 42 cubic meter. So for that we have to design one pond to accommodate this much volume. Okay, so that will do, we will do. First we need to find out the size. Okay, and then we will do the grading, okay, into the ground model, and then we will do the 2D modeling to see the scenario. Okay, so this much volume it is coming. For example, if we are going to put 2.5 meter depth. Okay, calculator, 16 142.11 divided by 2.5. So this much area we need. Okay, and if we are going to find the square root of this one, for example, we are going to put 30-meter width and 216 meter long length we need, and 30-meter wide and 2.5-meter depth. Okay, so this much we will do the grading. Okay, so this size of the pond we will do into the ground model. Okay, so we need to open the haircrash. All the grading work we will do in haircrash. Right, if we are going to do 1D, then we just need to create a 1D node, like a storage node, and then find to assign it. Okay, so yeah, where it is. Now we have a crash. Just wait, it's having something. Open project. Red fort is there. No, then I think it will be on desktop. Red fort. Uh-huh. OneDrive. A crash. Let's see if it's there. I think this one is terrain modification we considered. Let's check. No, no, this is not that. It is something different project. We had I think Datir. Let's see if it is not. This one is also not. No. Yeah, this one. Red for terrain. Sorry guys. Okay. So this one project we have. We will do the terrain modification. Okay. So this is the terrain. So this is the terrain. Okay. Over there we will assign. We need to define the volume. First we need to check what's the elevation over there. Okay. Almost 216 meter elevation is there. Okay. So 216. So we need to go to the lower down almost 2.5 meter below from 216. It will goes to the 213.5. Okay. So we will do. Okay. Sorry. Right click, modify polygon, or we can assign the and rectangular size. Okay. We can put pond. Name it is pond. Yes. Rectangular. Okay. Now we need to give the size 30 30 meter x and 216 meter wide. We will replace the value, so 213.5. Okay. And apply, close. Okay. What we will do, we can rotate it. Yeah, there's a portion. Okay. This channel we can drag out. Okay. So we have to move up this channel. so that it will comes on that way, like this. Is there two kind of channel? If we okay, we can remove this one, right? So now we can see what's the difference. It is coming like this. It's fine. Huh? It's fine. Over there is 2017. Now it is going to 13.5. Okay, somewhere it will be. So let's see. This pond will accommodate the flow of this area. Okay, so we will export this terrain. Okay, just save it. First we need to see what's the we will export this terrain as a raster. Okay, we need to give the name red for pond gm. Okay, ground model we will keep as a default terrain cell size, so we are not going to change it. This original extent we will export and click ok. So our terrain has been exported. Okay, now we will import into the ICM. Let's see what was the size of this terrain. Cannot be seen. No problem. Yeah. We can import now. Import ground model grid. Just we need to go to the haygrass, and this is the terrain. This is the pond terrain. We are going to keep it as it is. Meter red gm pond gm. Okay, so we got terrain over there. This is our scenarios. We will keep 1D, 2D with pond. Okay, we will copy the scenario this one. Okay, yeah, we will remove this ground model. We will drag out this one. uh, so as you can see, this terrain is not visible. We can delete this one. We cannot see the pond. So what we need to do, we will export the terrain as a 1 meter grid. Okay, export 1 meter grid. Then export it. So we have exported. Now we need to import. We can clear the ground and we can remove this terrain. Okay, again we are going to import the terrain. Just put the name JM03. Okay, you can see cell size is now 1 meter. Okay, now we have ground model. Just drag out this one. Okay, now you can see it. Let's see what's the size of this, how it is going. Okay, it's fine. Okay, no problem. That is the issue. When you see over there like this, it's fine. Okay, no problem. So what we will do, let's see what's the size over there. Okay, this will be out for 2D. Okay, we will do just remove its elevations and we will interfere the 217.5. But in what elevation it is coming? 206. Okay, so we made a mistake. We didn't check the invert. Okay, so our invert should be 2.5 meter below from this. So you're almost, it's going to be 204. 206.5 is already there, so we uh, need to go again over there and edit. Then go to payment and edit. Make it 200, 204 meter. Now that will be your pond. Okay, now again you need to export. the terrain. Why we did this one? Because our invert of the pipe, it is coming to under 6.492 meter. Okay, so our pond should be less than 2.5 meter below from the outfall invert of the pipe. Okay, so that water can accommodate within that. Oh, right. So that's why we did. We will export one. We need to change it 02. Make it 02 and export. So we have exported. Now we need to import in ICM. Right click, import ground model. Ground. This one GM04. Okay, we will clear this ground model and we will drag out this ground model 4. Now SC. Okay, we will drag out little bit inside this one. Okay, yes, 0 and interfere the regions is to 217. Then interfere results. Now it is 204. It is coming. Now it's the depth. Okay, that's it. Otherwise, you have to assign one slope range so that we can connect little bit above. Okay, so what we will do, we will do the channel things. We will make inlet channel like this. Replace the its inlet will be 206.49. It will goes up to 204. This kind of channel we are proposing. I think channel is going to be too long. We will do just 5 meters. Okay, like this. See, okay. Other one, no need. Let's see. Without this one, we will put at the bottom. Okay, little bit we need to drag out. Let's see what's the difference it is coming. No, just 400. That is because vertical slope is coming. Okay, we are connecting with the bottom, no problems. Okay, so we need to assign this 40204 meter, right? This will be our pond. Now we need to create 2D zone for this polygon. 2D. Okay, it will be verticals. And we will assign 20 by 10. Okay, yes, terrain sensitive, 0.1 meter. Sign will be make it the default, no problem. No rainfall, we are not applying. Filtration surface will be there. Okay, we can make it up to, we will use SCS value, right? Or we can assign infiltration. For example, IL, it will be. Okay, we will choose method. Okay, constant infiltration. Over there we need to put the rate, and over there we need to put fixed runoff coefficient will be 0.65, and infiltration rate will be around, mm, we can make 20 mm per hour. Okay, let's see how much time it will take to drain out the pond by infiltration. Okay, by these perimeters whatever we have assigned it. Okay, first now we need to create the mesh for this area. Model, sorry, go to mesh for this one. Take the ground mount for, your mesh created. Just load the mesh. Alright, just validate the network. No problem, just save the network. Okay, now you need to run. Let's update. And so this scenario, okay, 2D underscore pond. Okay, so see, for 48 hours, 24 hours, your rainfall will be theirs. But after 24 hours, you need to see the how much time will be taken by the pond to infiltrate the water into the ground. Okay, so we will increase for 48 hours. Okay, that's the reason to select this one, right? And just click to run it. Okay, just run it. So it will take a little bit time to run for to complete the 48 hours. Okay, thank you. So our model has been completely run, so we will review the results. Open it and just drag out the ground model. Okay, just properties and themes. We can optimize. Okay, and click maximum, so you can see the maximum flood water is there. Okay, let's check the section. You will see there's only 2.5 meter maximum depth it is coming. Okay, that's as we decided, that's the maximum depth will come. Okay, now let's see how much time it will taking to the drain out the surface this water. Okay, so let's see, you need to create the result polygon to see the attenuation curve. Graph result, see the volume enclosed by the polygon. Okay, see, that is going, it is the maximum peak, and after that it is simultaneously reducing. Okay, so our infiltration is little bit low. If we will consider higher, or we will continue the simulation for 3 to 4 days, so you will see your graphs will become like this, and it will goes down to zero. So it means that the volume inflow volume is coming for the 24 hours. See, up to the 24 hours it increasing, after 24 hours is continuously decreasing, and at that one point whole amount of this volume will be zero. So your graph will becomes look like this, and then down it like that. So this is the attenuation, so storage attenuation curve, which shows that how much infiltration will work out to the infiltrate the water. Okay, that's the design way to design the flow, and you can also see the maximum flood depth within this polygon or within this pond. Okay, see, it's going up to the maximum 2.5 meter and continuously is going to release. Okay, it will follow the same pattern as attenuation curve, because it is also showing that in the same respect the flood depth will also reduce. Okay, so this is the way to design the pond and analyze the pond. Okay, I will just show you the simple because it requires gradings. So to do the actual grading, you need to use Civil 3D, and this works will be done by the drafts, uh, say BIM engineer or architect. They have to be take care of the pond grading and the size. We can give just only the size, length and width and storage capacity and the volume and area. This much we need. So according to that, you have to consider it. Okay. For example, for same thing, okay, I will show you. See, for the same thing, what we will do, we are going to increase the infiltration rate. Okay. Okay. Yeah. We will do we are going to put almost 200 mm. Okay, 200 mm per hour. Okay, let's see. Okay, just validate it and save it the model. Let's try to rerun the model. Okay. Just update to latest. Run it. It will show you how this graph will going to the down. It will show the zero volumes within a time. Okay, let's wait. Just wait. It will take a little bit time. So our model has been completely run. So we need to see the result. Okay. So we can put it. We can off the mesh. Right, and this is our ground model. So this is our area, right? This is the flood depth it is coming. So we will see the attenuation curve, how much time it will take to completely drain out by infiltration. Yo, graph result and volume enclosed by polygon. Okay, see, this what is going to be maximum on this peak time 13:25. That's mean okay. Then after that is continuously decreasing. So it will take, because the in voltage is very high, right? So it will take only 45 minutes after 24 hours rainfalls. It will take 40 minutes after 24 hours. Okay, it will take 40 minutes to drain out the pond. Okay, pond will be drained after 45 minutes of the rainfall event. So that's the strategy to know the what will be the impact of the infiltration of the pond if we are proposing infiltration into the pond. If there is no infiltration, we have to put a zero, so there will be a storage, right? So that's the way to do the pond analysis. Okay, thank you, thank you.